Hi and welcome to Talking Tech. I'm your host Alejandro Hoyos, and today we're here in CES 2026 in Las Vegas, and we have two amazing guests with us. We're going to be talking about the latest Intel Core processor, Intel Core Series 3, that is just launching with us. And today we have Nish and Mitch. And Nish, why don't you start with we'll start with you. What do you do at Intel?
I manage the product management team, so I'm Senior Director of Product Management for Client Products.
And Mitch?
I'm one of the product managers on Nish's team, and I get to manage the Core Ultra Series 3 and Core Series 3 product family.
Yeah, that is great. All right, Nish, so we'll give us a little bit of a background on what are we talking about here. This product is formerly known as Panther Lake, but now it's becoming fully Intel Core Ultra Series 3.
Panther Lake is our first product with 18A technology, so we bring the US-based manufacturing goodness, our advanced packaging technology, and all the goodness 18A can offer, so performance per watt improvements and also density improvements. That paired with the architectural goodness we already have with Lunar Lake and Arrow Lake, so Lunar Lake battery life, Arrow Lake performance, put it all together, and we want to scale it to multiple price points and multiple choice points. So that is what essentially Panther Lake in a nutshell.
No, that's great. So we're still continuing that multi-tile approach and bringing all different things and hopefully make it a little more scalable.
More scalable, more affordable price points. And so a lot of people can enjoy all the battery life and performance goodness.
Speaking about battery life and performance, tell us a little bit more. How have we been able to achieve this?
The secret sauce is scaling that Lunar Lake low power island. So in Panther Lake, in Series 3, we've got new cores, Cougar Cove performance cores and Darkmont efficiency cores. And those 4 Darkmont efficiency cores that we have in the low power or efficiency island are how we're able to deliver a lot of performance, power gated off from the rest of the SoC. So you can run applications like your productivity applications, video conferencing, all on the low power island without lighting up the rest of the processor.
And if you guys are more interested in the details of the difference when it comes to architecture, a little go deeper, we actually have different videos covered also in our channel that goes into that. Today we're just gonna have a little bit of a higher level because we already covered that on those other videos. So let me continue with you, Nish. So we have all these different changes from your side. What do you think has been one of the most relative changes that we have done there?
Yeah, it's the most exciting part about Panther Lake is we've done the most difficult part of taking all the performance improvements we did with Arrow Lake. This means bigger caches, L3 and L2 caches which we had on the performance core is in Panther Lake. But we also took all the battery life improvements like Mitch was talking about, and which was in Lunar Lake, and was able to put it into Panther Lake. So taking both of them means you're going to get significant performance improvements, but significant battery life improvements. So like you saw on the keynote, we're getting 27-hour plus battery life with Panther Lake, but you're also getting close to 60% better multi-threaded performance compared to Lunar Lake. So significant performance and significant battery life.
And that is like you said, it's possible thanks to the marriage of these two different type of technologies, Lunar Lake and Arrow Lake, coming together and becoming this amazing product, which is Panther Lake.
Yeah.
So Mitch, tell us a little bit more about this. We're talking about the cache and all the different caches that we have in here when it comes to Panther Lakes. How they work, how they shared, what are those types of memories we have in there?
Yeah, so we've got the memory side cache like there is in Lunar Lake. It's bigger in some of the offerings for Panther Lake. And then within the GPU and CPU, there's bigger L1, L2, and then L3 shared caches as well. And that helps feed those IPs a lot more efficiently. The other thing that we've done architecturally different than Lunar Lake to make it more scalable, like Nish was saying, is we've gone back to more traditional memory. So LP soldered down onto the motherboard, or LP CAM, which is the compression attached memory module for modular LP, or traditional DDR5 SODIMM. So all of those changes actually help feed the processor in a both power efficient, performance efficient, and cost efficient way.
Now, that makes sense. Does that mean that you'll have like a specific product for each one of those types of memories? And sorry, go ahead.
Yeah. So with our flagship offering, we've got the Arc B370 and B390 built-in GPUs. That's running LP memory only, but up to 9,600 megatransfers per second. On the SKUs that have the smaller GPU, we offer both LP, LPCAM, and DDR. So depending on how we've mixed and matched the different IP, the OEMs have choice on how they build out those systems.
And that's pretty impressive that you mentioned that you can actually get 9,600 megatransfers per second, because that's a lot faster than we have in Lunar Lake.
Yeah.
And in Lunar Lake, we actually had the memory on package compared to here, the PCB. So it's a great improvement on the memory control.
Right. Lunar Lake is 8533, Panther Lake being up to 9,600. We're really excited about that, especially because now that we have the bigger GPU with 12xe cores, being able to feed it more efficiently for both graphics and AI workloads is a real big benefit, and we think we're one of the first to come out with 9600 in a client laptop.
Yeah, well, that makes sense.
A couple of interesting things is in Panther Lake, we have our ecos also in the performance cluster, which means that has access to what we call our last level cache or L3 cache. So in a use case like gaming, when you're gaming on your mobile system, you can put a lot of the performance on your eco, giving more power to the graphics so that you can get the best possible performance. If it's a graphics intensive game, now you're getting much bigger battery life if you're gaming on battery, or you're getting much better performance because you're balancing it right between that eco. So by having this flexible architecture and the right caching structure, we are able to eke out better performance or battery life depending on what you want to do.
That's pretty interesting, because as a gamer, you'll think like, oh, I just want everything to go to the performance course, right? Like performance course. But then you don't get to that point of thinking like, well, in a lab, the performance course, it also means battery, is energy consumption. But now with this new the efficient course, we actually balance that between the GPU and the efficient cores.
Absolutely.
Yeah, and I think on one of your ITT videos, you interviewed Rajshri, and she explained sort of how we do some of that, at least in the CPU with Thread Director. So if your audience is interested in diving deeper, there's that whole video.
Yeah, that is a great video on power management and also in the Thread Director that is also being revamped in Panther Lake compared to previous generations.
Yeah.
Yes.
That's great. One thing that you brought up that I want to ask, Nish, is like we have this new GPU. Can you tell us a bit about what's new, what it brings? There's also different flavors of it.
Yeah, so one, we wanted to be able to give the right level of feature set for the right users. So we have multiple flavors, like Mitch said. At the top, we have what we call codenamed 12xe, which is the Arc B70 and 90 level of graphics. This means 50% more graphics cores and twice as much as L2 cache. This alone gives significant performance boost. So compared to our Series 2, we get about 70% better graphics performance or gaming performance. That means you're now getting more discrete graphics-like performance. So even compared to a, say, 4050 thin and light laptop, we are able to get about 10% on average better gaming performance than that. So significantly powerful integrated graphics, and you're going to see this in multitudes of form factors.
That's amazing, because now you're comparing to 4050 discrete graphics card, and this is integrated. And also, I think you talked some performance compared to the competition also on the
Yes, so similar to what we said, Series 2, if you compare to a Strix AMD product, we will also be about 70% plus in terms of gaming performance on average.
That's pretty impressive. That is really good. So overall, you have two flavors of GPUs. So I guess I'll go back to you, Mitch. So that means that we have, I think, overall 3 different types of processors.
There's SKUs. 3 die package combinations that we have that make up the Core Ultra Series 3 SKU stack, essentially. So we've got flavors of CPU, big and small. We've got flavors of GPU, big and small. And we've got flavors of our PCD or IO die, big and small. And that's how we assemble that. The choice to make the 4xe, the smaller graphics tile, was about right sizing. For the user needs. So there's a lot of laptop types and user experiences that don't require that big Arc built-in GPU, and Intel graphics level of performance is great. Some of those examples are like our commercial type of systems where they're not specifically doing graphics intensive workloads. And then also some of the higher end enthusiast systems that will have an even more powerful discrete GPU. There's not necessarily a need for a big integrated graphics as well. So that's how we've kind of balanced that out.
Okay, that makes sense, because when I was looking at the specifications of the I/O, I saw like 12 PCI lanes, 20 PCI lanes for the. So you have you can't correct me if I'm wrong. You have like an 8/16 core?
Yeah, so we've got an 8 core. We call it the 8 core. It's got 4 P cores, 4 LPE cores, just like Lunar Lake. It's got the smaller GPU, and it's got the smaller PCD, or smaller amount of I/O. And that one's really going to be great for commercial, in particular commercial large enterprise, some of maybe the more cost-sensitive type of designs. And then we go up from there by putting in then the big 16-core CPU with the bigger PCD. So an additional 8 Gen 5 lanes for attaching discrete graphics, and then keeping that smaller built-in GPU. So that's great for mobile workstations that have professional discrete graphics or enthusiast systems. And then we've got sort of the flagship, which is 16 core, 12XC. And then because we didn't expect OEMs to want to attach a big discrete GPU on top of a big integrated GPU, we paired that with the smaller PCD. So those are sort of the 3 flavors that build out how we make our SKU stack across Core Ultra 5, Core Ultra 7, Core Ultra 9, and then the ones with the ARC built-in GPU are X7 and X9.
Oh, that makes a lot of sense.
One more small thing. Normally, when we do product launches, my mom always says, you do not build something for me, because I have to wait for another 3 years before that gets cheaper. Now with Series 3, we also have a core version. So all the performance, productivity, performance goodness, and battery life goodness is going to scale down in that price point and available in a similar time frame as with our Core Ultra Series 3 family. So we will have a Core Series 3 family, which is going to sit underneath what Mitch was saying, scaling a lot of those goodness down to lower price points.
That is pretty cool. So we have the Intel Core Ultra, and then we have Intel Core, which will benefit from all of these advancements that we have on the, I guess, of the Halo.
Correct. Yeah. It's all the same IP, so same CPU IP, NPU IP, GPU IP, just scaled down to the things that most mainstream users do.
Oh, that's pretty cool. So one thing that you said that what I like to mention and emphasize for the people who are viewing is, like, for those who are looking at for their highest ARC integrated graphics, it should be the Ultra X7 or Ultra X9.
Right. And you'll see that listed also as with the built-in B390 GPU.
Okay. I also see that we have a new generation of NPU, the NPU 5. Can you tell a little bit more about it, and also everything that is kind of related to AI and also AI workloads?
Yeah, if we don't mention AI 3 times, the AI gods will strike us down. So we have to. Joking aside, yes. So NPU 5 is basically taking the NPU we have on Lunar Lake, and we've been able to be more area efficient and shrinking it down. So you get similar performance to a Lunar Lake, like in terms of the NPU. But with Panther Lake, like we talked about, we have a big graphics engine. That also has XMX, or systolic AI, with AI acceleration on the graphics. So think of it as, if you want significantly boosting performance, you will go to the graphics. If you want something to run consistently like an AI agent, but you want to save battery life, you would run it on the NPU. And for things where you want to be able to, like OS, you want to be able to be in the same memory flow, you would put it on the CPU. So Panther Lake is one of the CPUs compared to our competition, has all 3 engines optimized. So for example, if you take Geekbench AI, we have significantly anywhere from 20 to 70% better compared to competition, where in many cases, in some of the engines, competitions won't even run on those engines. So we have the right tool for the right AI need on the PC.
Right, because depending on the AI workload, there's a specific accelerator or optimized accelerator for that type of workload.
Correct.
So that's pretty good. Like for NPUs, will be depending most of the things that you want to background, power efficient, and that kind of things. But like you said, you go to throw a punch, something quick, then you have the GPU.
Yeah, so if you're doing if I wanted to say create a video with Alex doing parkour, then to generate that, you would want bursty, big performance, like a stable diffusion, AI video generation, that will go on the GPU. Whereas your Copilot Plus, any of your AI agent will run on the NPU. So you can ask it to do tasks, it can go do stuff in the background, that will go on the NPU.
Oh, that's pretty cool. It's pretty interesting. There's also another block that I saw in there. This is the IPU. So is there anything you can bring guys talk about it?
Yeah. Well, yeah. So the IPU, it's our new IPU 7.5, and we've kind of earlier was focusing on the LPE cores as kind of one of the ways that we deliver great battery life, because that is pretty significant. But even technologies like the IPU 7.5 helps in video conferencing camera usages, in particular laptops with MIPI cameras, to deliver great video quality in sort of a whole host of lighting conditions and at lower power than a traditional like USB-based camera in the laptop. So those kinds of things help extend battery life and really create best-in-class systems.
Yeah, I was pretty impressed with all the different things that you can do with the IPU, the image processing unit. Like you can actually do a lot of AI work before the image gets shown into your laptop, to your screen. Like it grabs the image from the camera, process it right away, and then is able to display it, which is pretty interesting.
Yeah. I mean, I think JJ mentioned this. We spend more time in front of our cameras video conferencing than on a holiday. And a lot of the time, it's how you show up on that video conferencing may influence your conversation. And whether it's lower lighting, whether it's not good camera quality in terms of color, all of that could be corrected using a little bit of AI running real time on the image processing unit. And with our image processing unit, you don't sacrifice battery life to do that. You're able to get all those goodness without sacrificing battery life.
All right, so we have talked a lot about the processor itself, but is the system is just not. This is not just the processor; it's a whole platform. So, what other platform features that Panther Lake brings to the table?
Yeah, I mean, we've got our latest Wi-Fi, so it's Wi-Fi 7 R2, and then dual concurrent Bluetooth 6. So the dual concurrent Bluetooth 6 is going to be great for running different signals on different channels, also extending the range to double what we have today. Additionally, we've had built-in Thunderbolt 4 for a long time, four ports of Thunderbolt 4, and then optionally you'll see some of the OEMs implementing Thunderbolt 5 as well for that highest amount of I/O out of the system.
With Auracast, with our new Bluetooth, you can actually stream the same content to two different headphones at the same time. So if you're on a plane watching movie with whoever you're traveling, you can do that.
So I'm going to put you guys on the spot. When can we start seeing these type of systems in the market? When can I go get one?
By the time you publish this video, they'll be for sale.
Okay, that is awesome.
Yeah.
Well, guys, thank you very much, Nish and Mitch. Thank you so much for being here with us. Appreciate it, and I hope you guys have a great show here at CES.
Yeah, thank you.
Thank you.